Trigonometry review. Working with expressions in Tahoma 2D, there are functions that we will use to understand the relationship between points on the picture plane, angles between those points, and to understand points along a circle or possibly an arc. I found a good site called Math is Fun, and on that site there's a section for Introduction to Trigonometry. And trigonometry is the branch of mathematics that we're interested in, which gives us the formulas that we will need to work with the picture plane in Tahoma 2D. Trigonometry is about right-angled triangles. Let me scroll down here. And the link will be in the description for this website. We see here the three formula and a nice diagram showing what they refer to as the included angle, the opposite side, the hypotenuse, the adjacent side. And we can come to understand that this helps us because at the center of, at the starting point of this triangle, let's say, we have an XY coordinate, and we're trying to find the angle to this other point, or we're trying to find the distance to that other point, which would be the hypotenuse, or we're trying to find maybe the y value of that other point, which would be the opposite side. The distance from 0 is what that would give us, assuming 0 is the adjacent side is laying on the y equals 0. So you can see there's a little bit of translation that you'll have to do in your mind, or conceptualizing to think about how this triangle will overlay onto an image and prove useful. But there's more details on this page that go into some examples. Up to the point where, let's say we're, using a real world example, they're measuring the height of a tree, knowing the angle that they start with, the distance between the ground and the top of that tree, and they're able to calculate the height of that tree. That's similar to cases where we'll need to calculate the y-axis for a point within the picture plane, and the formula that we would use to do that. So I suggest you take a look at this site and look at some of the diagrams that are out here. This is an interactive one showing the relationship between the triangle and points on a circle. That could be useful, and that's something that is probably review if you've had these math concepts before. But I find this site and this page in particular to be very useful in explaining the formulas that we will be using within the expressions in Tahoma 2D. Those functions are listed on this page within the documentation. We can see that sine, cosine, tangent, and then two of the inverse tangent formulas are listed, arctangent and arctangent 2. Now, I wasn't familiar with arctangent 2, so I looked that up, and I found this page on Wikipedia. And you can see it talks about the Euclidean plane, which is the X and Y plane that we deal with when we're working with two-dimensional computer graphics. And it's giving a picture over here which shows you the included angle and the X and Y points. And you can see that's very similar to what we just saw on this Math is Fun page. So this is a formula used to calculate points on a circle that we will be using. And it's also used to calculate the angle between 2 points on the Cartesian plane. So you have your starting point here as the center of this diagram, and then the XY coordinate of the object that you are trying to get an angle to. And there's a formula to calculate that angle, arctangent 2. So this is a very good summary, and I'll have links to these sites within the description. And these are things that allow us to do some of the things that you see here. This is a ball that's moving, and these rods are pointing to it, and the red dot is indicating their center of rotation. And this happens to use that arctangent 2 formula. And this is another expression, and this one is coordinating different columns, keeping them aligned based on that arctangent 2 formula, plotting a point on a circle. You can see these rods that are following the wheels are maintaining their position as those wheels rotate, and that's using that arctangent 2 formula. Okay, so that's just to give you an overview. That's what I wanted to cover about the math that will be useful in the expressions that we do within Tahoma 2D.